As said, I'm from Nordic Semiconductor, and my name is Sigurd Hellesvik. I work in technical support, so my job is sitting at the forum, and when customers have issues, we answer them. An example could be like, after 2 days the Bluetooth stops working, and then I will ask them for a log, and then we take it from there and help them solve the problem. I will pick up the thread from Etteplan a bit, because at the start of the day, Etteplan talked a bit about regulations and that they are coming, and that we don't know exactly what they will entail. Now I will tell you how we at Nordic Semiconductor will try to solve this problem in our devices. But first I will talk a bit about us. Nordic Semiconductor is a fabless semiconductor company. We make Bluetooth chips and other wireless chips as well. We are the leading one in the short-range connectivity market. And for Bluetooth low energy, we have had over the past 6 years over 40% of the Bluetooth low energy market share. We also, a couple of years ago, made a product for cellular IoT with LTE-M and NB-IoT. And quite recently, actually I think it was last month, we released or told you about the ECF22 series, which does Wi-Fi 6. We are founded in Norway, and worldwide we have over 1,300 employees. In all, and there's R&D in these. Then you can see our products. There's the 52 and the 53 series, which does short range, Bluetooth Low Energy, Matter, Thread and Zigbee, and other proprietary stuff. The 21 series is a range extender. Then for cellular, we have the 91. The offices for the 91 are here in Finland. Using your good knowledge of that. And with LTE-M, NB-IoT, and GPS, it's perfect for asset trackers and similar applications. The Wi-Fi is dual band, so it's Wi-Fi 6 dual band, and it has low power. So we're hoping that will be good. And we also have a PMIC, so that if you want to use a battery with our devices, you can use our PMIC, meaning that for us in support, it will be easier to support you with that. You can of course use other PMICs as well. At the plan, cover this in the start, I will talk a bit about the regulations in case some of you weren't here earlier today, but it will be a lot less in depth than they did. Embedded security is not new. It's been around for quite some years. Here in Finland, I have been worked with SIM card security, and there's also in payment cards. It's been around for quite some time. But on the other side, there's people getting it wrong. A typical example is cameras. Your camera in your home has been hacked, someone is filming it, a hacker in some other country, right? We all heard about those. And the challenge here is that the developers themselves will have to decide, or so far have decided how secure they want the product to be. And to add to that, it's very hard to promise that the product is 100% secure. If someone with the right amount of time, money, motivation, and as we heard previously, if someone has a quantum computer, then you can't promise that your system cannot be broken. So, as a developer, how would you know what's the point of making your product secure if you can't make it 100% secure? Well, of course, it's a balance. And I pointed to scale. So you can see at one side, there's the risk of attack, which is not only how likely you are to get attacked, but also how bad will it be if someone hacks you. And on the other side is the cost, with memory, data consumption, and other things. And also, of course, developing hours. The more money you spend on something, the more likely it is to be more secure. And if you then say that you spend more money and on it, the risk of attack will go down, and vice versa. So, okay, we know that it doesn't necessarily have to be 100% secure. You can have it more secure or less secure. But as a developer, how do you really know how secure to make it? And that's where regulations come in. And regulations, as Etteplan said, is mandated by government, so you need it to be able to sell your product on the market. And to fulfill the regulations, which are quite, it can be vague. There's standards that you follow with the details. And then to prove that you actually follow the state standards, it's typical to send your devices to a certification authority, usually a testing facility, and they will test it and stamp it and say, yeah, it's secure. And since it's certified, it will be within the standard and it will be able to sell in the market by the regulations. Now, if you look at the existing products out there, for medical equipment, there's already some requirements. To explain the figure, you can see that there's a line, and you see more securities on the right side and less securities on the left side. Well, for IoT, in general, customer IoT products, it's up to the developer, as I said. So a lot of products will be placed all across this line, someone here, someone here, someone here, right? We don't know. And the hope with the regulations is to establish a baseline. For example, this stuff here, or maybe even further up. And then with the baseline, then some of the products already on the market will be secure enough, while others will not. But with upcoming regulations, all new products to the market will have to be above this baseline to sell them on the market. Now, at the plan, of course, went a lot more in detail about the regulations. But you can see but the point is that with a lot of the different governments and organizations coming with requirements, and since Nordic Semiconductor is a radio company, we do short-range and cellular and Wi-Fi. For example, the red is more relevant for our products, and with those coming up with security requirements as well, we can see that to create IoT products, it will be important to have security in your product. And since it's coming up relatively soon, we've already started to think about this. Another point to make here is that some of these say labeling and not regulations. And that would be that you can put a label on it and then the consumer has to choose if they want it safe or not. That will of course depend on the market. If we're in a market where consumers care more about security, it will be harder to sell your product. Now, and another problem here, or issue challenge, is that you don't know yet what exactly the standards that cover these regulations will be like, because they're not finished yet. So, what Nordic will do is that we will take an approach and choose something that we believe will be within the standards, so that when they come, we are ready for them. And what we work with is what is called the ARM platform security architecture. It is by ARM, of course, shown to BSA, and it's a set of standards and other specifications that tell you how you can design your product securely. You can split it into 4 parts to simplify it. And let's start with the 2 in the middle. There's a hardware and firmware architect specifications. Meaning that for us who make the silicon, it's easier because we can know which parts go into the hardware that we need to make the product secure. In addition to this, there's also a firmware architecture that we can put in there so that we know that we make it secure. It comes with source code, firmware source code with the implementation, which makes it both easier and we at Nordic will have a better time making the firmware secure. For the ones making the end devices, PSA also have some threat modeling tools. You see it there, yeah. And with those, I'm going to talk a bit about them later, but the gist is that you can go in and you can do a threat modeling to see how secure you need your product to be, and you don't really have to guess. You can follow like a document to see where you go get it. And of course, the most important one here is that they have the organization PSA certified for certification. It is created by ARM alongside a lot of other big security vendors. And they do certification for both the silicon, so you will see later how some of our chips are already certified with this, along with software and end devices. Meaning that you can already get your devices certified It is, as usual, an independent lab evaluation, so you send them into somewhere, or they do a review of your case, and then they stamp it and say it's certified. And the reason why we believe that PSA certified will cover the upcoming regulations is because they are working hard to align with existing and emerging standards within this, such as the ECF 303-645 and the NIST 8259A. And also others. If you go to the webpage, psacertified.org, you can read about the work they do to align with standards. In addition, they also align with ecosystems, such as, for example, Matter, who has built-in security requirements. So now I've outlined the challenge and how we intend to solve it. So then I will go a bit into the details on how PSA certified works. They have 10 security goals. And some of those you might have heard about before. It makes sense, like secure boot, secure update, secure storage, and some you might not. They have good documentation about this on their page. But the point with this lab is that there are 10 of them, but you don't necessarily need all 10 of them in your product, because as I told you, the baseline might go with some of these, but you don't need all of them to be within the regulations. That's why PSA certified has 3 different levels, level 1, 2, and 3. Level 1 has the least depth of testing and the least of security and covers security principles. While if you go to level 2 and 3, they also cover software attacks and hardware attacks, and what's inside them, how robust they are to these things will vary based on which level they are. And of course, the testing will vary thereafter. And we believe that PSA certified level 1 will be within the baseline set by the regulations. I should also point out that for level 1, it says it's a lab review, meaning that they review your product and they don't take it for actual testing. And for level 2 and 3, you send it into the certification facilities, and then they will do more testing on it. 3 of our chips so far have already been PSA certified for level 1. It's the 9160, the 5340, and the 52840, where the 9160 does cellular, and 52840 and 5340 does Bluetooth or other short-range protocols. There's of course both hardware and firmware here in the picture, but the main hardware parts is a cryptographic module that does cryptography, so that is separated from the application processor, as well with a key storage hardware peripheral, so you can save your keys separate from the normal flash. And if I'm going to talk a bit more about PSA, and when we go further than level 1, isolation is an important principle, so we'll spend some time talking about this. I like to use an example here. Imagine that this blue blob is an elevator, an IoT elevator, that's connected to the internet. And then it can control the speed that goes up and down. If someone attacks your elevator through the internet, then they can control the speed of it, which will be dangerous, because they can put it to the top floor and go fast down. Of course, you will never connect an elevator to the internet, but maybe someone do someday. Now, with isolation, you can split it in 2 in the middle here. And then on the bottom, you put the elevator controller, which controls the speed. And then there's an API in the middle that lets you only choose from the application which floor you go to. If someone then attacks your elevator from the outside through the internet, then they can only choose which floor your elevators go to, which is frustrating because your elevator is now stuck in one floor, but it's not dangerous. And so this showcases one of the uses why isolation is good. It's also useful for private keys, so that your private keys is harder to reach from the application, and also cryptographic modules and libraries. Of course, you should also have security in your communication layer. But with security, it's always better to have multiple layers, so that if someone goes through the first one, they will still have another layer to get stuck at. And to explain, the PSA has an APIs that you can use for this already, and TFM is for Trusted Firmware M. and it's only the firmware implementation of these APIs. Maybe some of you have heard of the Trust Zone hardware, and that's we got that in our 53 and 91 series, and it is what's used to do this isolation. And to do some advertisement, we have examples for this already in our NRF Connect SDK, so you can go in there and try this on our kits. Another figure here that shows you more in depth on what is inside. So, as I said earlier, there's hardware and firmware architecture specified, and this is how the firmware architecture looks like. I won't go into detail on all of this. But we will, in I think 1 or 2 weeks, release a blog post which goes more into detail of all of these that you can look up. And of course, there's also the PSA specification that goes even more into detail. And the blog post I mentioned will also reference the specifications. But just to go over it quickly. On this side, there's the application, the code you write, and as well as normal library to use and some real-time operating system and other things there. And then you split it from the rest of your memory. And here you have what's called the secure processing environment, or the secure part. In there, we have the bootloader, secure bootloader. That's what we call a root of trust. And the point there is that as long as you can trust the bootloader on the bottom, then you will be able to trust the secure part of your application as well. In addition to this, there's an updatable bootloader. Why do you have 2 bootloaders, you ask? It's because then the secure immutable bootloader can be very minimal to make a lesser surface for bugs and vulnerabilities. And you can also have more features in an updatable bootloader that you will be able to update if you find some errors in it later. The bootloaders, of course, let you update your application in case there's some issues with that and you need to update it. On top of this, you have the core, which lets you communicate in between all it takes. It handles all of the trust and firmware things in here. I don't have time to go into exactly what it does. You also have some services here. These 3 boxes to the right are mostly the same. That they have some services that follows these arrows and can be used in the application. For example, like the elevator API I talked about earlier. There's also some pre-made services that you can use that comes with trusted firmware, such as cryptography. And that's to go over that quite quickly. But as I said, there will be a blog post out by us, so if you keep your eyes out for that, it will open for that. You can read that to learn more about this. Oh yeah, I should also mention that you can see you will also be able to put on multiple isolation levels, because more layers of security is better. But of course, there's the balance, how many layers do you need compared to what your product needs. Then to talk a bit about the threat modeling. If you go to psacertified.org and search for threat modeling, you'll find a document showing you how to threat model. I will go over the simplified 4 steps that you do here. First, you identify the assets. What do you need to protect in your device? Do you need to protect your keys, certificates, anything else? Then you figure out what are the attack surface. Where can people attack you through the internet? Does your device have Bluetooth? Do people have physical connection to your device? Things like that. Then you figure out what's the risk and what's the likeliness of me getting attacked. What's the impact of you getting attacked? Will it hurt someone? Will it take picture? Will it take data? Right? And then lastly, it helps you mitigate the risk by implementing features to protect, to secure your highest risks. Another really nice thing here is that they also have examples that you can follow. So that and they have those examples for a lot of things, such as asset trackers, smart water meters, network cameras, speakers. So that if your product is close to one of these examples, you can go in there and learn how the example did it to figure out how you can do it yourself. I like to work that way, at least. And then some slides at the end. For Nordic, security is top priority, and we will continue to work with it. For you guys, I would advise you to start thinking about security early in your design, because it will be easier that way. If you add it later, it's harder to implement. If you start early, it will be easier to implement. If you want to get started, go to pcacertified.org, and you can have a look at the shuttle link there. As I told you, we have examples in our NRF Connect SDK, where you can just take one of our development kits, you can plug it in, run the samples on it, and you can see how it behaves with security, and then you can put the security example together with the Bluetooth example, and then you have something that's close to ready. Well, there's probably some more work to be done in that case, but in addition, we have DevSum. It's our forum for technical support where I work. It is free to use, so any of you can just go there and create a case and ask about anything, and we'll answer you or refer you to the right place. And we also try to answer your cases within the next 48 hours, I think it is, within the next workday. So that and we have, I think it's close to 50 people working every workday with helping you guys, if you want to use our products. And DevSum, as I mentioned, the link is quite simple. We have a lot of people using it if they want to use it links. We also have the blogs, guides, and tutorials. So the blog on TFM, Trusted Program, that I talked about will also be on DevSum. And if you want to get started by our products, I highly recommend Dev Academy. It's a step-by-step guide on both how to install our products and also run them. And we have webinars if you like to sit and watch people like me speak. And since you're here, maybe you like to have a nice time. And I think that's what I have.